Hello, it's Mr. Miller again. Welcome to video 10, Compound Inequalities. Let's get started. Some new math today. Compound inequalities are inequalities formed by taking two basic inequalities and putting them together, usually with an and or an or. So we're going to try doing this by using three number lines. Okay, let's take a look at the first problem here. The first problem is x is greater than -5 and x is less than or equal to 2. I want you to recall that and means both. So we want the values of x that make both of these inequalities true. Until we get really good at this, we're going to start by drawing each inequality separately. So x greater than -5 would have a hollow dot at -5 and go all the way to the right. X less than or equal to 2 would have a solid dot. And its graph would go all the way to the left. And I know you guys are really good at these basic inequalities. Now it's a matter of putting them together. So on the bottom number line, we're going to do the final graph. X greater than -5 and x less than or equal to 2. So I got to look at which values of x are on both graphs. If I look at -6, only the second graph has any points there. The first graph doesn't. Where I get both starts at x equal -5. So I'm going to put a hollow dot there because -5 is not on both graphs. But everything to the right of it is, all the way up to 2. Okay, so this is where I have both graphs. So a hollow dot at -5 and a solid dot at 2 and a line in between. So remember, and is what's on both. So if I kind of look, I start getting both at -5 and I have both graphs going on until I get to 2. And then after that, there's only the top graph. So my final graph here at the bottom is the final answer. Those are the points on both. If I wanted to write this in interval notation, by the way, I would put parentheses, -5, comma, then a 2, and close the parentheses. It's all the numbers between -5 and 2, and including 2. Okay, let's go to the next example. Let's start by graphing the simple inequalities. So x greater than or equal to 0 is going to go that way, and x less than 4 is going to have a hollow dot at 4 and go to the left. And again, I'm looking at which values of x are on both. Okay, so I see that I start getting both at 0. In fact, 0 is on both graphs because it has a solid dot in the first one and it's part of the second one. So let's put a solid dot at 0. And we see that this ends at 4. At 4, I'm going to put a hollow dot because 4 actually doesn't belong to the second graph. And I have x in between those values. So my solution starts at 0 and includes 0, goes up to 4, but not including 4. Again, I just want to practice interval notation. So this begins at 0, includes 0, so a square bracket, and then an open parenthesis at 4. That's how we'd write that in interval notation. All right, this is our last example for and. So let's take care of this one. This one we have to think about just a little bit. So x is greater than -3 goes to the right. X is greater than 1 goes to the right also. So I have to keep in mind what I'm looking for. I'm looking for values of x that are on both graphs. There are no values of x on the graph around x equals -5. We start getting one graph kicking in around -3, but we don't get both graphs started until 1. So I'm going to put a hollow dot here because 1 is not on both graphs. And then everything greater than 1 is on both graphs. So that would be the graph for this one. And if I wrote it in interval notation, open parentheses, it starts at 1 and it goes to positive infinity. Then open parentheses. That would be the interval notation for that one. All right, we're half done. But let's switch to or. Remember, or means which values of x are on either inequality or both. Okay, so it's kind of like combining graphs. Remember, or means union. So here, our first inequality is x less than or equal to -2. So start with my graph, solid dot, and to the left, and then x greater than 4, hollow dot, and to the right. Now, I want all the values that are on either graph. So remember, or kind of means either. If I could spell either, here we go, either. So I want all the values of x that are either on the first graph or the second graph or both. So all these values count from the first graph. So I'm going to go ahead and copy that. X less than or equal to -2. All those are on the first graph, and I'm going to copy all the ones that are on the second graph. It's like union. Union is when you combine things. So when I combine these graphs, I get the one below. This is a little bit harder to write using interval notation because it has two pieces. But we can do this. This goes from -infinity to -2. I'm going to put a union symbol because we're combining these two intervals. Union, oops, this should be open, 4 to infinity. Okay, a little messy, but there we go. So, all right, let's try another one. X less than 1. So put a hollow dot, I'm sorry, -1. Put a hollow dot at -1. Go to the left. X greater than 2. A hollow dot and to the right. This is an OR, so we want all the values that are in either graph. So we're going to have all the values from the first graph put together with all the values from the second graph. All right, so my last graph represents all the values of x that are on at least one of the graphs, at least x less than -1 or x greater than 2. Since it has two pieces, interval notation is going to need two pieces. This goes from -infinity to -1, open parentheses, union, 2 to infinity. Okay, so the union means we're putting these two pieces together. All right, last one. This one's a little bit different. So 3 is our boundary point. We're going to go x less than or equal to 3 to the left, x less than or equal to 5 to the left. All right, I want all values of x that appear in at least one of the graphs. So if I look from -6 all the way up to 5, all these values are in at least one of the graphs. So I'm going to put my solid dot there and go to the left. If I look up, every value in my bottom graph is on the top two graphs. Okay, this time it only has one piece. So for interval notation, that go from -infinity up to 5 with a closed bracket. We're going to practice this a lot in class, but I want you to kind of get a feel for it. Plot the two basic inequalities, then think, do we want values of x that are on both graphs or either of the graphs? The journal assignment. So copy the following figures in your journal and graph the inequalities. So remember to graph the basic inequalities first. So graph the first inequality on the first number line, the second inequality on the second number line. Then pay attention to whether it's an and or an or problem. Remember, and means both, and or means either. Okay, good luck. See you in class.